we have a 2 by 2 matrix, so here's a note for you. Let A be a 2 by 2 matrix, A, B, C, D. If AD minus BC is not 0, as you remember, this is the determinant of the matrix from elementary algebra. Determinant of AD minus BC. When the determinant is not 0, then we can say that A is invertible or it is non-singular. What's the meaning of that? It means that it has an inverse. We have a nice formula to find the inverse of a 2 by 2 matrix. A inverse is equal to, what I'm going to do, you're going to write 1 over the determinant AD minus BC. Then you're going to flip the elements on the main diagonal, D and A, and you're going to opposite the terms B and C, minus B minus C. This is going to be the determinant of a 2 by 2 matrix with a nice formula. Let's go over an example. Suppose matrix A is given to you as 3, -1, -2, and 2. And I ask you to find the inverse of this matrix. Find the inverse. Well, I might say that I'm going to apply the new technique that I learned at joining matrix A and I, and apply Gauss-Jordan elimination method and try to convert this into I and inverse of A. So let's try. In this case, you're going to have 3, -2, -1, and 2, joining by 1, 0, 0, 1. Well, you're going to say that, hey, the very first element must be 1, but unfortunately it is 3. So we're going to divide the very first row by 3, or multiply every entry by 1 over 3. And this is going to be your new first row. You're going to get 3 divided by 3, so let's just write down the whole thing. 1, -1/3, then you have a third, then you have 0, and your second row, -2, 2, 0, and 1. Below 1, you must have 0, which is -2. So I'm going to multiply the first row by 2 and add it to the second row. 2 times R1 plus R2 becomes R2. So 2, -2/3, 2/3, and 0 added to -2, 2, 0, and 1. So of course this is 0. Then here you have 6 minus 2, 4/3, and you have 2/3, and you have 1. So this guy becomes your new second row. So you have 1, -1/3, 1/3, 0, and here you have 0, and here you have 4/3, and you have 2/3, and 1. So now we're going to check the second row. This time must be equals to 1, which is not. So we're going to multiply everything by 3 over 4. 3 over 4 times R2 comes your new R2. Very good. Let's see. So this guy becomes 1, and you have 2/3 times 3/4, a half. And here you have 3/4 times 1, which is 3 over 4. So far, so good. Then above 1, you have -1/3, which must be 0. So we're going to multiply the second row by 1 over 3 and add it to the first row. This guy becomes your new R1. So 0 plus 1 is going to be 1, and here you have 1 times 1/3 plus a third. This is 0. Then you have a half times a third plus a third. This is going to be a third, and you have 3 halves, which is going to be a half, 1/2. And here you have 1/4 plus 0, which is 1/4. So it seems that we are done with the whole process. This is our identity matrix, and this guy becomes our inverse matrix. Remember that you can always check your work. How do we check the work? You can multiply A and this new matrix, and it must be equals to I2, identity matrix of size 2, but let's check to see if it actually works the way that you want. 3, -2, -1, 2. I have a half, I have a fourth, a half, and 3/4. This guy is equal to, so the very first row multiplied by first column, so you get 3 halves minus a half, which is 2/2 or 1. The first row by the second column, 3/4 minus 3/4, as you can see, it is 0. So far so good. Let us move on to the second row. -2 times a half, -1, and plus 1 becomes 0. And the second row by the second column. So -2, get -1/2, and here you have plus 3/2, which is 2/2 or 1. So as you can see, we end up with I2. So the inverse matrix is like this. But since we learned some new formula, let us apply this new formula. Since you have a 2 by 2 matrix, the determinant of this matrix is equal to 3 times 2, 6, and minus 2, which is 4. It is non-zero, so you can form the inverse of the matrix, which is 1/4 times, I'm going to switch the elements on the main diagonal, 2 and 3, and here you get 2 and 1. Okay. Take a look at this. This is a scalar multiplication. This guy becomes 2 times a fourth, which is a half, and a fourth. And here you have a half, and then here you have 3/4. This matrix and this matrix, as you can see, we have the exact same entries, but of course, this process is much more faster.